Let's compare linkage versus direct coupled. Historically, linkages have been more common. Control actuators were originally designed as foot-mounted actuators. A foot-mounted actuator has the mounting surface on the bottom and the drive shaft coming out the side. This arrangement works well with a linkage-type control. More recent control actuator designs are face-mounted. These newer designs make the mounting surface and the drive shaft on the same plane. With the mounting face, actuator shaft, and valve shaft in line, direct coupling the actuator to the valve is an improved design. With a linkage, the control actuator uses the full range from 0 to 90 degrees. The actuator settings do not set high and low fire of the control valve. Instead, the movement of the control valve is determined by the distances of the linkage. This arrangement follows the properties of a 4-bar linkage. If any of these lengths are changed, it will have an effect on the range and characteristics of the control valve. To set the linkage, trial and error with these distances adjusts high and low fire settings. For direct coupled control, the stroke of the actuator equals the stroke of the valve. To adjust the stroke of the actuator, adjust the cams located under the cover. This will limit the stroke. In this case, high fire is set by the red cam and low fire is set by the black cam. Using a screwdriver to turn the worm drive adjusts the cam. There are arrows to indicate the setting. This concept of cam adjustments in the actuator is commonplace for a direct coupled arrangement. The actuator being secured to the valve is critical to safe operation. The actuator being disengaged from the control valve is a major safety concern. With linkage, there are 6 secure points: actuator to crank arm to swivel head to linkage rod, and then double all of those for the valve side. There is confidence in the crank arms being secured to the actuator and valve. Usually these connections are a positive connection. The swivel heads are connected to both the crank arms, and the linkage rod is a connection with less security. Typically the swivel head is clamped or a set screw is pressed into the linkage rod. Under conditions of vibration or varied temperature causing expansion and contraction, these connections can and have come loose. Losing control of a valve has caused explosions. Because of this hazard with linkage, occasionally you'll see a position switch connected directly to the valve to verify valve position. With direct coupled, there are 2 secure points: actuator to coupling and coupling to valve. When done correctly, as shown here, both of these points are positive connections. The machining of the actuator side of the coupling is commonly an irregular shape, which doesn't allow the actuator shaft to rotate inside the coupling. On the valve side, a pin bolt goes through the coupling and the valve shaft. You can be more confident in a secure connection with a direct coupled arrangement. We can trust the actuator feedback signals to accurately reflect the position of the control valve. A position switch verifying the position of the valve is not needed with direct coupled, where with linkage, a valve position switch is more common. Because of the connections of a linkage are not rigid, hysteresis is introduced. The least rigid connections are the swivel connections. The actuator will push on the swivel head when driving open and will pull on the swivel head when driving closed. Earlier, we touched on how the lengths of the 4-bar linkage determine the movement of the valve. When the lengths are slightly different based on direction, hysteresis is created. For a given control signal, there will be two different valve positions. Why is this important? Hysteresis has a negative effect on emissions, efficiency, and temperature control. The inline connection of the actuator drive shaft and the valve shaft with a positive connected coupling eliminates linkage hysteresis. The coupling is a rigid piece which allows for the actuator movement to be replicated in the valve movement. Precise control is beneficial for emissions requirements, optimizing efficiency, and high performance temperature control. SCC has standardized on all valve actuator combinations being direct coupled for a safe solution and convenience of high and low fire settings. Thanks for watching and have a safe day.